Hello. In this tutorial, I would like to show you how to use the SIMBAD astronomical database to download some data on stars and actually make your own HR diagram from which we can actually look at a cluster and actually figure out the age of the star cluster. So the first part is just getting the list of stars. So here's the SIMBAD interface. Here's the database. And like a lot of these things, I can actually, if I click here on by identifier, I can just type in the name of something. See, I've done this before, and find out some stuff about it. I'm going to look at the cluster M67. I happen to know that that's the name of a star cluster. So I'm going to ask it about that, but I don't want to just query about that object. I want to go around, I want to get everything in the vicinity, and I want to get a bunch of stars. So I need to choose a radius of a bit more than 2 arc minutes. I want to choose, 30 gets me about 4,000 objects, which is plenty. But it's a big star cluster, so not all of these are going to be stars in the cluster, but I want to make sure I get enough stars that I can kind of see what's going on. So now I just submit that. And it's going to make, oh, it actually came back quick this time. Sometimes it takes a little while, depending on how busy the site is or whether they're doing maintenance or something, but here it came back quite quickly and it gave me a whole huge list. So really what I want to do now is I just want to find a way to get this list into a spreadsheet. So I'm going to try to, what I want to do here is I'm going to change the output options. So there's right at the top, there's this yellow button for changing output options. It's going to pop up a new tab, and it's actually already set up how I want it. But what I want is ASCII tab separated. That's what Google Sheets is going to like to have as input. And I want to make sure this file output thing is checked. And then everything else I can just leave how it is. But I need to save this to have it actually start working that way. And then I'm going to close this tab, come back here, and I'm actually going to reload the query. So let me actually reload the page. And this time, instead of giving me a big long web page, a second to download should come. I believe now it's preparing it. I can see something's happening, but not seeing the download yet. But if it doesn't seem to work, oh, there it is. Sometimes it seems like it's hung, but there it is. So a little window popped up. It said, okay, got a file, simbad.tsv. I'm just going to save that. I'm going to save that to my downloads folder. There it went. And now I can import that file into, if I happen to have Excel, I could just import it into there. That would be nice. Or I can use on the web Google Sheets. I'm going to do the web option because I don't happen to have Excel on my computer. But let's go to that and do that next step. So I'm going to pop open a new window. Close that, come window. I'm going to go to Google Sheets, sheets.google.com. I need to sign in with my Hamline account here. And here I have it. I've already downloaded this file before and uploaded it, but well, actually, what can I do here? I can import, even if I hadn't, I can import. I can actually click over here to upload, and I can select a file from my device. Here's simbad.tsv. It's going to upload. There it goes. Here's some options, but these are just fine. It'll do most of the stuff automatically. Click on import data. It'll take a few seconds because this is a lot of data. It's 4,000 stars here, over 4,000 stars. But here it is. Here's the spreadsheet. Let me zoom in a little bit so you can see more clearly what I'm doing, but I've got a lot of info in this spreadsheet. First few rows are just sort of an overview. I don't really need that, but I'll just leave it the way it is. And then I have a whole bunch of columns. First column is just a number. There's some other columns with names of stuff in here and coordinates. But to make my plot, what I need are these magnitudes. And I only want to plot stars where the magnitudes are actually known. I'm going to look at the V magnitude and the B magnitude. Um, so the vertical axis in the plot will be just the brightness of the star, and I'm going to use the V magnitude for that. The horizontal axis of the plot is going to be color, and to get that, I'm going to look at actually the difference between the B magnitude and the V magnitude. So I'm just going to subtract those two numbers, use that for the horizontal axis. But first, I want to make one column here just to tell me whether a row actually has numbers for those two things or not. So then I can use a filter to get rid of all the data where I don't have numbers for that. Because otherwise I'm going to have a bunch of just junk on I might have just a bunch of junk on the graph. First, I'm going to make a column that I'll just call good data. And here I'm going to use an Excel expression. Let me zoom in here so you can really see what I'm doing. Because I basically want those two columns to be numbers. And so I got two things that I want. So I need to use the AND function to combine two things because I want them both to be true. There's an isNumber function, which just determines if a column is a number or not. So I want to see if the B magnitude is a number, and I want the V magnitude to be a number. So I'm going to go over and select that. Then close parentheses, and so that's the formula that I kind of want for that column. It's basically just saying, are those two columns both numbers? So I'm going to hit enter, and in fact, for the first row, that they're not. So it's going to say false. So that's the first thing I want to do. And I'll copy this down in a second, but let me make my other two columns first. The horizontal axis, I want the color, which I'm going to use B minus V for that. And here I can just do this one minus that one, literally just subtracting the things there. So it gives me an error message because, of course, there aren't numbers in those columns, but that's why I had this first column. Do something. Then I need another column to the right here because I have space. Now I need a column. I'm just going to make a column for the brightness, the V magnitude. But I'm going to make it as a new column for two reasons. One, having it over here is going to make it easier to make the plot. And two, I want the brighter stars to be on the top of the diagram and the fainter stars to be in the bottom. But magnitudes, if you remember, work kind of backwards. Larger numbers means fainter. And so to get Google Sheets to do that, to sort of flip the vertical axis, I'm going to use net minus V instead of V. So that way the larger numbers will be more negative, and then Google will do the right thing and put them in the bottom. So I'm just going to call that minus V because that's what it is. Just to say minus equals to start an equation, minus, and then just that cell. Again, there's no number in that row. There's no number, but so it gives me an error message, but that's okay. So now what I need to do is I need to copy this data to all the rows. Fortunately, there's some nice shortcuts I can use to do that. If I go over to here where I have all these rows, like on this I don't know what that's notes. It's a notes column, whatever. If I go over here, if I hit Command down, or I believe it's Alt on the Windows, it'll go all the way to the end. If I hit Command up, it'll go back to the top. So that's kind of nice. That's useful. So what I'm actually going to do is go all the way down, go over here, hold down the Shift key. So I'm holding down the Shift button now to start a selection. I'm going to move to the right to get those three columns that I want to fill in, and then I'm still holding Shift. I'm going to do Command up. And that's going to go back up to the top. Now that I've selected all those rows, now I can hit the shortcut for just filling in the data, which is Command D or Alt D on Windows. And it's going to take a second. You can see a little bar on the upper right. It's thinking about this, but it's going to fill all those in. That's great. You can see that a lot of these rows I don't have data for, but again, that's why I filter. Okay, so I'm going to go back up to the top here. Let me make this a little smaller so I can see kind of the whole spreadsheet. Here I'm back at the top. What I want to do is I want to filter on the data, on the good data. So I don't want to use any data where I don't have numbers. So first, I just had to make sure that I have a cell somewhere in this spreadsheet selected, just not out in the blank areas, but have something in the actual data. I'm going to click on this little button up here, create a filter. That'll sort of automatically figure out where all my data is, and it does all this highlighting. So now above here on good data, I can click this little, that's how it indicates a filter. I'm going to click that little button there. And all I got to do now is uncheck blanks and false so that only the true is left. I only want the data for which I have both those columns are numbers. Okay. Now I can make my plot. And I really just want column P and column Q, so I'm just going to highlight those two. One's going to be the horizontal axis, one's the vertical axis, so I'm going to go over here to Insert Chart. It made a chart, but it made a bad guess as to what kind of chart I wanted. So over here in the setup where it says chart type, I don't want a column chart, I want a scatter plot. Almost always the case in science plots, but here we got a scatter plot. I've got x-axis is b minus v, exactly what I wanted. Series, which really means y-axis, is negative v, which is again actually just what I wanted. Fainter stuff is going to be in the bottom, brighter stuff in the top. So now I'm just going to make this bigger so I can see what's going on a little better. And now I just want to adjust some settings here on the plot just to make it easier to see what's going on. Because I can zoom in a bit because there happens to be this one weird thing over here. I don't know what that is. It's got a weird B minus V color. It might be kind of interesting to someday figure out what that thing is. But right now I don't care about it and it's kind of messing up my plot. I just want to look at this stuff in the middle. I'm going to go over here to customize. The first thing I'm actually going to do is under series, where it says format, there's a point size. I can make this smaller. It's generally going to be a good idea. So I'm going to make it 2 pixels instead of 7. Because I've got a lot of data here. I've got something like 4,000. Well, not all of the 4,000 things had both these magnitudes, but I've still got hundreds of stars here. Make those points too big, I'm not going to be able to see anything. I'll make those smaller. I could change the color if I wanted, or the shape, but I'm not going to bother with that right now. And then I want to come down here to horizontal axis. And where it says min and max, I want to change that so I can see more, because you can see there's not much less than 0. I want to go a little bit less than 0, so maybe -1. I could maybe even chop off a little more, but I'll leave it at that. And max, really, I mean, by 3, I don't really have any stars. So that looks a bit better, and I could even adjust this a little more, maybe -0.5 actually. And I don't know, 2.5 certainly would be fine. So there we go. And then I want to do the same thing for the vertical axis. So I'm going to open up the vertical axis here. Again, for the min and max, I'm going to look at my graph. Right now it's using a minimum of -25, but I could probably do like -23 without losing anything much. It didn't actually seem to change the figure. I'm not sure why. But I certainly don't need to go all the way up to 0. -5 would be plenty. There it changed. In fact, even -8 would probably be still show what I needed to show. And I could continue to tweak this a little bit. I don't know, but this looks pretty good. Now I can actually see my what's going on here. It'd be nice to put some labels on this. Here you can just chart and axis titles. You can mess with that stuff. I can make the chart title, okay, HR diagram for M67. Horizontal axis title, I'll just say B minus V. That's vertical axis is -V. And there we go. It's like at the M, M67. So there, I've got a fairly nice looking HR diagram. And in fact, what you can see here, there's a clear sort of diagonal line here from the lower right to the upper left. That is the main sequence of stars in the cluster that in M67, and there's a variety of stars there. You also see other stuff. Those are probably either, those might be weird things, or they just might be stars that aren't actually in the cluster. So they appear fainter. Maybe they should be up here on the main sequence line, but it's actually a star that's much further away than the cluster, so it appears fainter, for example. That's okay. We could try to clean those up a little bit, but for our purposes, if we can see the HR diagram, we can kind of get the info. The most interesting thing we can learn from this diagram of the cluster is we can look at, it goes from lower right to upper left. The lower right are the redder, more longer-lived stars, and the upper left are the bluer, shorter-lived stars. But at some point it kind of stops. It actually looks like it sort of curls upwards a bit and kind of stops. And it stops because at some point you don't have those stars anymore. If you had a star up here, it would be a very big blue hot star that doesn't live very long. And what this is telling you is that this cluster's been around long enough that those stars simply aren't there anymore. They've already gone up and died. So that helps us figure out the age of the cluster. And so one of the things that we might want to figure out is we can actually look at exactly where that ends, or at least get a rough estimate of where that ends. We can say, look, that ends right about here, and then we can look at the color there. We can look at the B minus V value. We can actually just kind of look up what type of star that corresponds to. Does that correspond to like A stars, B stars, F stars, G stars? Where is that cutoff? And that tells us, and then if we look at the age of those stars, how long those stars typically live, that actually gives us kind of a lifetime for the cluster. The cluster's been around right about that length of time, so that those stars that are right at the edge are just now blowing up, red giant phase, and dying. And so this is actually a real common technique used to age clusters. We do this for M67. You'll note it's actually a little hard to read values off of here because it's doing something strange about the labels. But we can change that too. There's a section here, grid lines and ticks. I can turn on a bunch of these minor ticks, major ticks, lines, try to have it show a little more about what's going on. And I could even want to do that for the horizontal axis too. So minor ticks, major ticks, minor grid lines. And I can change some options here. To make more of these tick marks. Try to get it to label things a little more clearly. So issue that I'm noticing is it seems to go like 1, 2, 3, but then there's like -1 here. So something a little bit strange about that, because you shouldn't really go from 1 to negative. There should be a 0 in between there. So I'm not quite, something goofy is happening with the labels. I'm just wondering if it's just kind of a weird bug in Google Sheets or something, or what on there. But you know what? I can click on one of these points, and or at least I thought I could. I missed it. Find out exactly where that point is. Maybe not. Maybe I'm thinking of Excel. Anyway, I can read off this chart. Let's say that maybe this -1 is actually should be a 0. That the B minus V is a little less than 1, where this cluster ends. So we can look up If we wanted to look up what kind of star, that's sort of the value that we would use. We use like maybe it might be like minus, it might be about 2/3 or something like that. So a B minus V of about 0.6, zero 0.7. That's where this cluster appears to stop having stars any more than that. And so we could take that number, look up which spectral type that corresponds to, and then look up the age along those stars' lifetimes. And that would give us an approximate age for this cluster. And in fact, if we do that, we do find out that this turnoff is, I think, somewhere in the F range. So that's this cluster is about 5 billion, 6 billion years old. Work that out. There are no stars bluer than, there aren't very many stars much bluer than our own sun in this cluster, because they've all, this cluster is quite old and those things have already died. So this is an old cluster. You pick another cluster and look at it, you might see different results. You might see this main sequence line go on for longer to a lower B minus V value, and that just corresponds to a younger cluster. And so this is actually an important tool that people use to date clusters of stars. All right, thank you for watching, and see you next week.